We are setting off on a journey to explore the universe and meet a true cosmic titan today. Get ready to discover the largest galaxy that has ever been discovered by astronomers. Envision a galaxy so vast that it contains trillions of stars and stretches for millions of light years. In this video, we will check out the stunning details of this galactic giant, how it was discovered, and what makes it so anomalous in the immense ocean of the universe. If you love such content, subscribe to the channel and ring the bell. Stay tuned and prepare to be amazed by the beauty of the universe. The Milky Way is a mass-dominated barred spiral galaxy, incidentally, where one would start searching for details before entering large observational phenomena. The Milky Way is slightly flattened circular at the equator, which is typically about 100,000 light-years in its diameter, housing around 200 to 400 billion stars along with our Sun. If we could view our galaxy from the outside, we might see a grand structure with graceful spiral arms winding around a brilliant core at its center. Assorted within the Milky Way are these nebulas, which just occupy constellations in space. The possible deaths of gigantic clouds of gas and dust are stars. Planetary systems have formed due to this stellar formation process. At the heart of our galaxy is a supermassive black hole called Sagittarius A, with a mass about 4 million times that of the Sun. Milky Way does not swim around in isolation. It is one of the members of an association called the Local Group that comprises at least 50 other galaxies like Andromeda and Magellanic Clouds. The Milky Way, like all galaxies, moves through the universe at speeds of roughly 600 kilometers with reference to the cosmic microwave background radiation. Thus, to understand the Milky Way is basically to have an idea about our place in the universe. Although the Milky Way is impressive, there exist those that surpass it in scale and complexity. Second, let's take Andromeda, our neighbor to the west. Also called M31, Andromeda resides about 2.5 million light-years from our planet's surface. It is a giant spiral galaxy of larger proportion, like the Milky Way. Its diameter runs to about 220,000 light-years, over twofold the size of the Milky Way. The number of stars seems greater since Andromeda is made up of about 1 trillion stars, between 2 and 4 times the Milky Way. This gigantic assemblage of stars and planetary systems renders Andromeda a magnificent galaxy. Andromeda is best known for its spectacularly well-defined spiral structure, with many arms streaming from a brilliant nucleus and containing a supermassive black hole, thought to have a mass about 100 million times that of the Sun, vastly larger than the black hole that resides at the center of our Milky Way. It's a pity to think that these two beautiful spiral galaxies will run into each other in just under 4 billion years before eventually merging into a large elliptical galaxy. After our beautiful, majestic Milky Way has been introduced alongside the impressive Andromeda, it's time for the largest spiral galaxy known, Malin 1. This barred spiral galaxy was first discovered in 1986 by astronomer David Malin and is one of the largest spiral galaxies in the universe. Its galactic disk has a diameter of about 650,000 light-years, about 6 times as much as our own Milky Way. A fascinating detail of Malin 1 is its low density. The stars in this galaxy are very thinly spread, and therefore, the galaxy appears to have a low surface brightness. Imagine a vast, very faint sheet of stars that goes on forever. This is the impression you'll get when you think of Malin 1. It's situated in the Coma Berenices constellation and is located about 1 billion light-years from us. It appears to be an anomalous galaxy, although its bar seems to be visible despite the rarity of such galaxies and despite the scattered and distant distribution of its starts. The galaxy contains a very significant amount of neutral hydrogen, from which stars can form. Even if the process of the gas-forming stars continues at a slow rate, it's true that, in certain areas, new stars continue to form, making Malin 1 an evolving galaxy. The existence of Malin 1 raises possible concerns to the theory of galaxy creation and development we're most familiar with, suggesting that there are other, different ways to form massive diffuse galaxies that are not just the result of lower energy. Methods of galaxy creation. This is the place for hazarding the meat of the genuinely gigantic galaxy, giant IC 1101, the second largest galaxy thus identified by astronomers almost 1 billion light-years from Earth, in the constellation of Serpens. This giant elliptical is indeed a cosmic colossus with a diameter of about 6 million light-years, which makes it about 60 times the size of our Milky Way and 30 times that of Andromeda. When viewed from the present-day position of the Milky Way, IC 1101 would swallow up not only our galaxy but also Andromeda, Triangulum, and other members belonging to the local group. The number of stars in IC 1101 has been estimated to be about 100 trillion, an unfathomable figure when placed against the billion stars in those whose galaxies we know about. This suggests that, if the average number of planets per star in our Milky Way is considered, IC 1101 should harbor about 200 trillion planets. The number of stars in IC 1101 brings it outstanding fame for being among the brightest and heaviest galaxies. Apart from its sheer bulk and exuberance, IC 1101 has its own specification. Contrary to being spiraled like the Milky Way and Andromeda, it has an elliptic shape. It is yellow in color, indicating it has a really aged lot of stars. Therefore, presumably it passed through a vigorous phase of star formation in the past, but is still quiet with respect to the future, in that it exhibits very little ongoing star formation. The core of AUS is thought to contain a supermassive black hole comparable in mass to billions of suns, being much larger than the supermassive black holes found in the centers of the Milky Way and Andromeda. This mega-black hole significantly affects the galaxy's dynamics, holding it together. IC 1101 illustrates extremely the various features along the size spectrum of galaxies. In studying it, we are closer to understanding the formation and evolution of galaxies in the universe. It is a testimony to the grandiosity and complexity of the cosmos, raising many questions and instilling awe with respect to the immensity of the universe. Some 3 billion light-years away in the constellation of Lynx, AUS was regarded as the largest galaxy ever discovered. Discovery of AUS in February 2022 coincided with an equally awesome cosmic discovery, as it proved to be the largest galaxy yet observed. It is the epitome of a cosmic titan, with a length of about 16 million light-years or 5 megaparsecs. To put it in perspective, AUS is about 160 times bigger than our Milky Way, and almost 3 times larger than IC 1101. AUS is a radio galaxy that emits powerful radio waves, houses a supermassive black hole in its nucleus, which pulls its great gravitational force into the surrounding stars. This black hole is incredibly massive and extremely active, ejecting immense jets and lobes of material from its core. Jets and lobes form when matter is sucked into the black hole and heated to speeds close to that of light. Some of it, after being accelerated and escaping, is ejected away from the black hole, thus forming a flow of highly energetic particles. The original jets interact with the interstellar medium to form enormous lobes of radio emission that can get stretched over millions of light years. These phenomena indicate the intense and ongoing activity of the core of the galaxy. The discovery of AUS reveals how little we still know about the biggest structures in the universe. It redefines our understanding of cosmic scales and the varieties of galaxies. AUS is not only the most gigantic galaxy uncovered, it also provides windows into the most extreme phenomena acting around supermassive black holes. Throughout this video, we brought forth some of the most eccentric galaxies history has been able to witness, from our Milky Way to the supergiant AUS. But among the wider universe, does the fact remain: are there any other titanic galaxies still waiting to be discovered? The universe is large, let's be honest, and rife with enigmas. Each new observation, coupled with technological advancement, means that scientists continue to challenge the frontiers of our knowledge. Galaxies like AUS remind us that the cosmos always has surprises in store, and that perhaps there are even larger, slightly more distant galaxies awaiting discovery. As our observational equipment advances, so it is that we are working with an increasing number of instrumentations discovering, exploring, and even imaging such gigantic structures. New technologies such as the James Webb Space Telescope will provide an even deeper look into the intricacies of the universe, enabling us to go into more distant reaches and to fathom the true nature of the forces that shape these colossal galaxies. The future of astronomy should be bright. The search for far more significant, far more massive, and more mysterious galaxies must continue. Who knows what other cosmic giants are yet to be uncovered? For certain, the universe will never run out of wonders to reveal and teach us. Thank you for being with us on this fascinating voyage through the cosmos. Don't forget, if you like this show, like it, subscribe to the channel, and ring the notification bell so you won't miss any content. Until next time, explore the universe with us.